Hey everyone, and thanks for coming along to the session. Talking about infrastructure using .NET with the AWS Cloud Development Kit. Hopefully it should be obvious who's who, but if not, I'm Steve, technical evangelist at AWS.
I'm Nikki, senior software engineer here at AWS on the Amplify team.
Okay, so today we're going to be talking about infrastructure as code using the CDK, or Cloud Developer Kit, which was launched, generally available back in, I think it was July at the New York Summit.
Yeah.
And .NET bindings for the CDK went GA a week or two ago, something like that.
Very recently. It went GA in July for Python and TypeScript first.
Yeah. So it is a multi-language framework, but we now have .NET support, which is awesome. We're going to go through what the CDK is. So if you've not seen it, it's fine. We're going to walk through an example later on using all the commands and things. But for the most part, we're going to be spending our time in demos.
We're going to be doing a lot of demos after we talk you through like what the CDK is and then like how you would use it. And then we're going to basically just go to demos and do demos for the rest of the time. Mm-hmm. We'll also take questions live. There's a mic here, I believe. Make sure you come up to the mic and like eat the mic so everybody can hear your question. And we can too.
Okay. Some related breakouts, deep dive into the city. I think some of these have already gone, but you can look these up on YouTube after the session. And there was also a workshop. I don't know if those will go live, but if you get a chance to do it and it's still available, highly recommend that. Okay, so what is infrastructure as code? So this is infrastructure as declarative template. All right, this is a CloudFormation template in JSON. CloudFormation is our infrastructure provisioning service, right? You give it a template of things, declarative template that says, these are the resources I want to spin up in the cloud. And it goes off and does it, all right?
And you know, this obviously what came out of like a need to version control your infrastructure, right? There was a true need here that CloudFormation served a purpose when it first launched, was like, I need to be able to version control my infrastructure, see changes, keep track of things, or redeploy the same application to multiple accounts. So CloudFormation is obviously a great resource. You've probably used it or touched it somehow at this point. But it's still infrastructure as code, right? Because it's JSON or YAML. It's not really code. It's like kind of, but like not really. So how about we look at?
Well, I want to say a few more things about this before we get into this, because it's going to affect some of the demos. So you can see on this example, if you've not seen this before, resources, right? This is where we declare the resources that we want. You can see here we're spinning up a Elastic Beanstalk application. Above that is a parameters section. So we can parameterize these templates, right? We can customize them at deployment time and change values, etc. But we don't have a lot of flexibility here. We don't have any iteration, right?
Nope.
We have some support for conditionals in a declarative language, so we can kind of do a few conditions and do this if this.
They're not always easy.
But they're not easy, and it's very limited. So we really want to take the power of our programming language. I don't know about you, but I don't spend all day in JSON or YAML files. I spend my time writing C# or TypeScript or whatever happens to be the language of the day, right? So
how about infrastructure is code, like truly code, and that's what the CDK is. So there's a couple of key terminology that we need to like explain that is regarding the CDK. So first thing is a stack. So you see here, right? It says ECS Fargate sample stack. You're probably familiar with what a stack is if you have a CloudFormation stack, or it's the same concept, right? It's like all the resources needed to create that stack, be it like an application or a piece of the application. And then there's a construct. So what is a construct? Well, a construct is actually, it could either be like one service, like all the things in that service, like a base class almost for that service, or you could have higher level constructs that do very similar patterns. So maybe you have a pattern where you always create a VPC, you always create a cluster, and then you always, like everything in this, you can create a higher level construct to basically do that pattern and use that as a class and just enter the parameters to instantiate it, essentially.
Yeah, so one common construct you might consider is my company spins up virtual private clouds, right? VPCs inside the AWS cloud. Here are all of the security settings, including security group ports that are open or blocked, etc. Encapsulate that into a construct and then share that with the other devs in your org or your DevOps team. So you always get this consistent experience, okay? So we have a concept of an application composed of one or more stacks, composed of one or more constructs, either constructs from the CDK itself or constructs that you've written or third parties have written. Okay.
The CDK is an entirely open source project, so we highly encourage you to contribute to it. Not all of the AWS services even have constructs yet, so you're welcome to contribute, especially if you find that there's a missing construct that you need, and also create higher level constructs for multiple people to use based off of those similar patterns that we all come to know and love.
I don't know about love, but yeah.
I love some of them.
Okay. My clicker's not working. Now my clicker's working. Okay, so here's another example. This is Hello CDK World, but this is an example where we're subscribing an SQS queue to an SNS topic. Now it's a handful of lines of code there, but in CloudFormation, that would be a fair amount of JSON or YAML, right?
That's the fun part, is writing CDK and then watching the CloudFormation template spit out and see how many lines of CloudFormation it is. So obviously this goes into like what is really happening when I use the CDK. So we talked about the source here, which is the application, which is composed of stacks, and then constructs within that. And then you use the CDK CLI, which is another part of the CDK, to basically compile the source and have it spit out the CloudFormation template, which is essentially our like assembly language in this case. And then you can deploy that to CloudFormation, which is our provisioning engine that would actually go and provision all the resources for you in AWS. You can also just skip the synth step and also just go directly to deploy, which we'll show you as well.
Yeah, so if you don't want to see the template, fine, just do deploy. It's very cool. Now, the key thing about this is that even though this is .NET, if you've used any of our other .NET tooling, you might be familiar with our .NET extensions for the extension for the .NET CLI, for Lambda. Here we're using the CDK CLI, so you do need to install that. It's installed to be a node. So npm install AWS-CDK, but once that's installed, you use it just like any other command line tool. And we're going to go through a bunch of examples of that.
Probably want to install that globally too, so -G.
Okay, the main components of the CDK then. So we have a core framework, which is the CDK provided constructs that we have for the various services. Well, the core framework, the CLI, etc. The different language bindings, so TypeScript, Java, C#, Python, JavaScript. Did I miss one?
JavaScript, TypeScript, Python, C#, Java. That's
it. That's the set. The construct library, so the core construct library, the construct libraries that you have inside your organization that you can share, those are written in TypeScript. So you put them into an npm repo. And then the CDK CLI. And that's all it is. It's really simple to use. So I say, why don't we get on with the demos?
Let's do it.
Nikki's going to go through live coding demos because she's the only one that can type in front of a bunch of people. I cannot. So I'm just going to stand and watch.
Well, TBD if I can type today.
So we're just waiting on the switch over. There we go. Yay.
Cool. Okay, so I'm going to use the CLI to create a new project. And I'm actually just going to go into, so we put all of our demos that we're going to do live for you today in a repo. I'm just going to go into the folder of the repo and just create new stuff there.
So the first example we're going to go through is, well, first example, Hello World. But rather than just printing out something like Hello World, we're actually going to do an S3 bucket website, right? So we're going to take some content, upload it to S3, and configure that bucket as a website, just to get you started on using the CLI.
We should just create a folder like live demos. I'm going to be smarter about this.
Okay.
Be organized.
You do that. So the first command we're going to use is called CDK init. And that takes a language switch to emit a project template. Okay? So in this case, language C#. Custom resource? Not Hello World?
Oh, whoops. Doing that one.
That's later.
Well, I just created that one for later on.
Okay, we got that for later.
Wrong order. Okay, I'll do another one. You're going to watch the same command again. Oh, I got to create a directory for it.
Yeah. Get control of your command prompt.
What? Oh, I didn't go into it. Struggle.
I promise you this would be even worse if I was typing this.
Okay. So I created a .NET solution.
So that gives us a solution and a project file and two source files, a program CS, which contains the application that instantiates the stacks that we're going to define, right? And the stacks are defined in another C# file. In this case, we have hello world stack, okay? So all we have to do is replace that code with that app.
Yes, but we need to add the specific modules, so they get added as NuGet packages. And you actually want to make sure that you're always on the same version. I have definitely made that mistake before, and it's ruined my life. I want to talk about it. So I just copy and paste it just to make sure. So I'm going to add, we're gonna create a bucket, and then from that bucket, we're going to host a static website to that bucket. So we're going to have to add S3.
It's AWS.S3. So the naming convention is Amazon.CDK is like the core parts of the CDK, and then the NuGet packages for AWS services are Amazon.CDK.AWS.ServiceName. Okay? And then there are also some higher level NuGet packages that we're going to use, one for S3 deployment of the static website that we'll show you as well.
Okay, so we got to import.
Yep. So the first thing we want then is a bucket.
Yep, let's create a bucket. The bindings actually give you nice IntelliSense, I think, so. Okay, so we want to give this bucket some properties. So the first thing we want to give it is a name. Reinvent, live, demo. They have to be globally unique, so I want to make sure I make this long.
The other thing that we need to do is, because this is going to be hosting a static website, by default, the bucket, there's no access. There's no public access, right? So we're going to turn on public read access. Now, that's not going to be enough for our static website to work, right? Even though it has public read access, you still can't get to the access to the objects that are in there. You can just see the bucket. So we're going to fix that later on by adding a policy that's going to permit that access. Okay, so we've got our website index. That's our home page. Now what we're going to do is add, I believe, the policy, right?
Yep.
Add to resource policy, yeah. You can see there's a common pattern developing here, right? Every construct takes this, which is the stack the context that we're running inside. A name, a logical name. That's not the name of the actual resource that will be in the cloud. It's a logical name inside the application, okay? And then a set of props, which is optional to configure that resource.
Well, actually, I think we don't actually, it's not a separate package for IAM.
Yeah, IAM, you need Amazon.CDK.AWS.IAM.
Yeah, thank you. Just needed to include it. Okay, now I can get rid of this.
Okay.
That's better, right? You guys can see. Okay, so we want to basically write the policy.
Our effect is allow, right?
Yep.
We're going to allow access to the contents of this bucket.
And then actions.
Actions, yeah. So what actions are going to be permitted on this bucket? In this case, it's going to be the S3 get object access action.
Okay. Then, which resources we want it to affect?
So now we want it to access all of the resources in this case, all the resources in the bucket. Now we could put our static website in a key prefix or like a folder inside the S3 bucket. In this case, we're going to apply to everything in the bucket. Now to do that inside a CloudFormation template, you need to form up an Amazon resource name, okay, which is a colon delimited string identifying the resource. The CDK gives us a helper object here. On for objects on the bucket construct. Here we can pass in a string that identifies the key prefix path or the objects that we want to permit access to using this policy. In this case, we're just going to specify star, meaning everything. And then the principles of who's going to be allowed to do this.
Which is any.
Any. So our bucket will now have public read access. Anyone that goes to the bucket can see the objects inside there. That's done. Now, the only thing we actually need to want to do is actually deploy the static website. Now, if I was doing this from a CloudFormation template, I'd have some external build that took those static website artifacts, bundled them up somewhere, and then handed that off, subsequent to deployment. With the CDK, we can do it as part of the CDK stack deployment. Okay, so here we're going to use a new bucket deployment, which is in a higher level namespace for S3. Amazon.cdk.aws.s3.deployment, I believe it is, which we'll need a NuGet package for.
It's not deployment, right?
I think it's deployment.
All right, we got to add it.
Yeah, you're going to have to add that.
Yep. For me, this is my best practice of making sure that it's always the same version. Obviously, you can use commands.
And we'll need the IAM reference in there as well.
No, I think it's included as part of the CDK.
Oh, okay. I learned something. Hey.
I'm pretty sure. Guess we'll find out, though.
We'll find out. Okay, so now we just need to code up that deployment step, right? So we have a set of assets that we've already got for this static website. Don't get too excited, it just says hello world. But we have them on a folder on our machine as just a set of loose files. What we can do with the CDK is have those loose files considered as assets for this stack. And then during the deployment process, the CDK will zip those up, send them off to, I think in this case, S3, S3 deployment, and then deploy them down onto the bucket for us using a Lambda function. It's going to just create and do itself. I don't need to go and define that, right? It's really convenient.
So yeah, you have to give the destination bucket, which is the same bucket that we established up here.
And notice that we're not giving it the bucket name here, right? We're just giving it the C# object that we created inside our stack, right? The CDK will do all the wiring up of the logical to physical assets as part of it generating the actual template.
Okay, so CDK has this really cool feature that I'm going to show in a bunch of demos, but we're going to talk a little bit about it here, where you can actually pull in an asset using a path. And so the source of the deployment is obviously just a static website, right? We need to actually just go add that to our project, which is sitting in another file right now, and then we can just refer to the path right here. So we can do like, if it is in this path, like that.
And the CDK will then take care of zipping up that as part of its operation.
So you call from like a local asset, essentially. And this is the really, really cool thing here is going to come into when we do a containers example, because when you call from the local path to the container, it will actually basically call Docker build for you. It will tag it and push it to ECR, and we'll see that a little bit later on. But I think like this local asset is one of the coolest features about the CDK. Okay, so I need to pull in.
Need to go and grab those files?
Yeah, I'm gonna go grab it. So there's another one in demos. Oh, I gotta go back out.
Back level 2, yeah. That should have demos in it. Oh, repo. I think it's called.
That one.
Yeah, that's it. Demos, hello world. That's it, and then I think it was site contents. Yes, everything inside there is what we just want in our site content here.
Oh, I have to do -R.
You are in your site contents folder, right? Before you do that copy.
What?
Well, you're currently sitting in live demos hello world, so we want that to go into a site content, site-content folder to match up with the source code.
I don't want it there. I want it at the root.
You want it at the root, yeah.
Okay. Cool.
All right, so there's our simple app, right?
I didn't think we needed that extra folder because it actually just created a folder inside of a folder.
Oh, move that up then.
Okay, 1 sec.
Okay, you happy?
Yeah, I'm happy. Okay, so now we have site contents. Okay, and then the last thing that we need is we wanted to grab the output, right?
Yeah, we want to take the bucket URL, the bucket website URL, so that we know what to go access. And we can use that with a CFN output construct. This is part of the core CDK framework. And what will happen is, if you've used CloudFormation templates before, then you know there's like an output section, right? You can refer to the logical resources. This is all that's doing. You just identify the resource that you want to actually output, give it a name, and you'll see here we're just going to use bucket name. It's actually a bucket website URL in this case.
Yeah.
Okay.
I think that's the one. All right, cool. So now we basically have our stack.
So I think we should go and take a look at the generated template. Okay. So to do that, we run a command called synth. So CDK synth from the folder where you have the CDK JSON file will output the template, and it outputs it in YAML format by default. Oh, you need lowercase.
Oh, it doesn't like my bucket name.
It has to be lowercase. Now you bet you wish you had a shorter bucket name, right?
Yeah, but you can't because they're globally unique. At least that was a good error. Mm-hmm. There it is.
And there's our template. Okay, so that's a lot more lines than we actually entered in our app.
So it does spit out the CloudFormation right in the terminal, but you can also just view it by going to cdk.out and then clicking on the template.
Yeah, and notice that asset folder that's appeared there as well. That's the site contents.
Yep, it zipped it up.
All zipped up, ready to go.
So this CloudFormation template is
336 lines.
Yeah, and our code is reaching 34 lines.
Yeah, right. So big product, and we didn't have to go back and forth trying to figure out the JSON for some complex, policies, etc. We just coded in what we code in day to day, C#. Right?
That's right.
So now I think we should perhaps deploy it.
Let's
the ultimate test, deploy to prod. Okay.
You got it.
To do that, CDK deploy. Now, because we're creating a policy and attaching it to that bucket behind the scenes with that add to resource policy, the CDK knows that there are permissions issues involved with this. It wants you to confirm first.
Which is the same thing as like if you've ever used CloudFormation CLI and you've added capability IAM.
Yeah, that's what that's doing. So we can see it. The CDK has updated the asset zip file. So it's taken that set of static files for the website, created a zip, uploaded it, or will upload it. Now, all this work is done using CloudFormation change sets. Okay, so we wait for the change set to be validated. Now the stack's been created.
And we should get that output when it's done.
We should get the bucket website URL, yeah.
Now we just need CloudFormation to be faster.
Yeah. Actually, while it's doing that, let's take a look at some of the other files that are inside that project folder. There was a cdk.json file. Let's go and take a look at that, because we're going to look at some of these later on. So you see here that this has a command line in it. This is how the .NET code is run by the CDK CLI to do that synth work and do all the template generation, right? And you can include other data inside here. Later on, we're going to show an example where we're going to pass parameters into the stack using this file, using what we call the context, which has a number of advantages over using CloudFormation parameters that I showed you in that template right at the start. Remember that little parameter section? I'll tell you why we do it differently in a second, well, when we get to that demo anyway.
Looks like it's almost done.
Almost there. So it's created the policy.
My bucket name was globally unique. No one had taken that name.
Yeah.
Which I'm very surprised. It was reinvent demo hello world.
Not too much longer.
Nope.
You'll notice there's a Lambda function just been created. If you look at the output, we didn't specify a Lambda function in our code, right? That's the deployment piece. It's creating a Lambda function that's going to take that static website zip and deploy it out onto S3, okay, for us.
That's one of the coolest things is that what we're going to show in the next demo, which is just like a very, very small demo to do something like very common, right? Set up an S3 bucket and set up the trigger of the S3 when something gets created, send it to a queue. Well, if you've ever done that before using CloudFormation, you actually have to create a custom resource because you have a chicken and an egg problem, right? You need the bucket to be created, and then you need the queue to be created to be able to give the queue ARN to the bucket to then basically add the event notification. So you have a chicken and egg problem, and usually if you're creating CloudFormation, you have to create a custom resource, which ends up being a Lambda function that basically tells CloudFormation when the bucket has been created to then go create the queue and then give the queue back to the bucket. And it's a whole process, which you've ever done it. It's pretty difficult. It's not that easy. And CDK will just do it for you. That's one of the things I love about it.
So here we can see the output from running that stack. So outputs, there's our bucket output that we created. That's CFN output, and we have a URL, and hopefully we get a web page. All right. So we coded 36 lines of C#, give or take a few braces on lines, etc., and instead did the equivalent of, what was the length of the CDK, the input template? 360
it was like 300
lines? Yeah.
something lines.
Right? And that was a simple example, right? You can imagine that if this was a real-world stack with a whole load of resources, you can imagine the size of these templates, okay? This is a great productivity boost, great time saver.
Cool. Should we do another one?
Well, I'm wondering right now, what are the commands we have available before we do that? So there is you might think, well, if I change my stack, if I change my code, what happens? How do I know, what change is going to happen? There's a tool called CDK diff, and this can diff the stack against the running, your local code, against the running stack and tell you what new resources can be created, properties changed, etc. So let's just change just one thing inside there.
Let's just add SQS and create a new queue.
Yeah, you might need some props on that. Did you really type let?
Oh, whoops, sorry. You know, I switch languages all the time, and I can't keep up. Do you know how many times I've switched languages just today alone?
You're going to need a queue
had to
props
add
on
it.
the end. Oh, and the queue, yeah.
Yeah. No, I was going to add a SQS queue.
In that case, it might be optional. Down a folder. You're in the.
Oh, you're right.
Yeah, it's in the source folder.
Cool.
Okay. I think
Using.
And then using, yeah.
Okay.
All right, we're good.
So now we can do
So back at the
CDK
command
diff.
line, we can run CDK diff. Oh, you need to go back up one, remember?
Yep.
You're in source folder.
Yes, I do.
I keep multiple terminals open, one in different places to do this.
Yeah, I do. I usually do that.
And you can see it's telling us it's going to create a new queue. All right? So I don't have to go and kind of guess or diff JSON templates or YAML templates. I can just change my code, run CDK diff. Oh, you're going to create this. You're going to change this property, etc. So it's pretty cool. So we went through CDK init to get our project bootstrapped. But you can do it yourself, obviously, once you know what to put in the files, but it's a time saver. CDK synth, CDK deploy, CDK diff. And of the three, unless you really want to look at the template, you don't need to use CDK synth. You can just do a deploy. Now, some people obviously might want to take that template and check it into source control as well as the code. I have heard people say that they want to do that. Fair enough, but I very rarely use CDK synth.
So let's do one of those custom resource examples that I was talking about. So clearly, I was really excited to do this one earlier. And okay, so super common use case with the bucket and the queue.
And the reason we're showing you this now is that we are going to use this later in another more real-world example where we are going to wire up bucket notifications to Lambda functions. So it's good to know about this now.
Got to add all my necessary packages.
You memorized this one, didn't you?
I know the packages involved. I just typed them all like 2 seconds ago. So there are 3 constructs here, right? There's the S3 construct. Then there is a specific notifications construct that is for bucket notifications, right? So I want a bucket trigger. And then there's the SQS construct. not gonna type let, I promise. Oh, I gotta add the using statements. All right, so we have 3 things we need. We need S3, we need SQS, and we need notifications on S3. All right, so we are going to create a bucket. And we don't really actually need to give it a bucket name.
No, we don't.
We could probably just pass no props here.
Yep.
Now we need a queue. Okay. Now we want to add an event notification to the bucket. An event type is an enum, so we can select object created, but you can see you can choose any of these. And then now we want to actually add a destination. So when something gets dropped into the bucket, where do we want it to go? We want it to go to the queue. So we're going to add a new SQS destination and pass in the queue. And that's basically it. Now, the fun part here is actually watching CDK synth, because then you can go find that custom resource code that was auto-generated for you.
So you just did effectively 3 lines of code, ignoring all the class.
That's right.
bits.
I did 3 lines of code. Okay, so first of all, 182 lines of CloudFormation.
Yeah. So where is the custom resource inside here?
Let's find it.
So there's the bucket.
Hold on, it's like right. It's always hard to spot. And oh, here it is. Look, this is a custom resource that is a Lambda that is going to basically, look at this code right here. This is going to respond to CloudFormation.
You need word wrap.
Well, yeah, oh, but you get the idea. There was a bunch of code that was written in this Lambda that is now going to respond to CloudFormation. This is a CloudFormation handler, which is really cool because obviously none of us wrote that. We just basically declared a bucket, a queue, and added an event notification. All right, let's go to the containers.
Let's go containers, yeah.
Okay, so this one is definitely my fave by far, because this one uses a higher level construct called ECS Patterns that the containers team built for us, which is so nice. So this is the construct right here. Sure, fine. Okay, so if we look at this code, which let's give ourselves some more real estate here. We are creating a VPC, then we're creating a cluster, then we're creating a Fargate task definition. And this is actually where we call to get the current container, which is sitting in the root of the path.NET app, which is right here. And inside this .NET app, there is a .NET application. It's not doing a whole lot. There's a Docker file, okay? This Docker file is just spinning up this .NET app. Pretty sure I basically just did something out of the scaffolding. It wasn't nothing crazy. Oh, I created a React app in the front end too, just so we can have something to show. Okay, then I have container definitions. So this right here, I call from asset on this basically folder in the root directory. And then when I do CDK synth or I do CDK deploy, it will actually find that Docker file, run Docker build, tag it, then push it to ECR for me, and then deploy the entire stack and connect the tagged container in ECR to the task in Fargate.
Now, what's extra cool about that is that inside this code, there's no mention of ECR, right? We're not spinning up an ECR repository.
I also didn't have to write any Docker commands.
Or any Docker commands, right?
So I designate a port mapping, container port, and the host port, and I add the container, which is, remember, the container is just that local file that it's going to create an image from the local files. And then I add it to the task definition, because that's what I want the definition to run, that one container.
So here we're adding constructs to constructs, right?
Yep. Then I add the port mappings. And then I can create an application load balanced Fargate service. So this right here is from that ECS Patterns construct. So they know that in order to create a load balanced Fargate service, that's something that a lot of people do, and that would have had us define a couple more constructs, but instead they wrote one higher level construct, and we can just basically instantiate it and pass it everything that it needs. So that's this is one of my favorite ways to use the CDK. Okay, so let's see how many lines of CloudFormation this one is.
I like how you have this approach of, what has it saved me?
I always want to know how many lines it is. I want to know how many lines I wrote to how many lines I would have written if I wrote just straight up CloudFormation. Come on. You guys feel free to come up and ask questions too.
Oh, actually, while that's running, can you just click on the program CS file? This is something I wanted to show you in Hello World that I forgot about. Here's the program. So you can see we just have a static void main, just regular C# code. Notice it instantiates an app object, and I can pass settings into this app object as well. Here we're passing null. But you notice it's instantiating that container stack class, right, an object for that. I can instantiate as many of those as I want inside here. So if I wanted to, if you think about it, the container stack code is like a template, right? I can instantiate as many of these as I want, all with different names, different settings, etc., all from inside this code. Now, in a CloudFormation template, that would be a lot of copy and pasta, right, to do that. Right? If I wanted to spin up, say, 2 EC2 compute instances in a CloudFormation template, then I have to define my first resource and then copy and paste for a second resource. There is no iteration. All right? The only way to do it is to actually effectively do an auto-scaling group and say, I want 2 instances. Right? Here, I can just instantiate as many of those stacks as I want. And the CDK, when it runs synth, will output a template for each individual stack instance that you've run. It's not one combined template. You get multiple templates output.
Okay. What was that?
1,523 lines of JSON.
CloudFormation?
Yeah.
And this was about 50 lines
about that.
of code?
Yeah.
About?
About.
Some of it I didn't write. It was some part of the scaffolding of the class.
So are you going to deploy this?
Yeah, I am going to deploy
cool.
this.
So while this is deploying, apart from the CDK CLI, which is node-based and installed from that, using the CDK with .NET is pretty much identical to using the AWS SDK for .NET. Right? We add the new packages that we need, we add the namespaces, and we just start coding against it. What did you fail? Docker build.
This is the same error, though. Actually, updated, though. There was a bug in CDK a couple weeks ago where it was unable to identify the symlinks in a Docker file because, again, it does call Docker, see, look, calls Docker build for you. Definitely upgraded my CDK. Weird. Okay, let's go into it and see if we can just call. Okay. Make sure that it's actually the CDK and not me.
While that's running, has anyone got any questions? There's a couple, cool.
Coding, so this was awesome. Just on your previous project on line 21, while creating the action, you actually did S3 colon some kind of action, I think.
Yeah, get object, I think.
Like an IAM policy action.
Yeah, but that could have been, it's a string at this point of time, but it could have been enum, I believe, because these are kind of.
It could have been an enum.
Yeah.
Would you like to contribute to the CDK and help us out?
And you didn't, just to clarify, I don't know if this came across in the code demo, but that was actually an array of strings or an array of enums, right? So we don't have to just do it one by one by one. We can give it an array of all the things.
Right, because we probably add policies that have multiple, features.
But still, since it's strongly typed, that's what we want to go for. So enum would have been a better choice.
Yeah, it's moving that way. I mean, when we did the effect and the
did you see the
that
effect was an
right?
enum, and then also the event type for the notifications was an enum. I think it's definitely going in that direction, but feel free to contribute to make the.
Awesome.
Because I agree with you, typing IAM policy over and over and over again should be an enum.
Another thing is you're copying the packages on the project every time and copying the same version. So that means when you create any version, you create multiple versions of all the other namespaces. That's how you are creating different modules. Because
so the only reason I'm
reusing
doing
the same
that is
versions.
because I want to make sure it's the exact same version. Because if you have packages that, so like let's say you start up a CDK project today on 1.1.8, which is released, right? And then like 2 months from now, you update your CDK and you basically install a NuGet package for SQS. You decide you're going to use a queue. If SQSQ installs at 1.1.9 and the project's on 1.1.8, you're going to have issues.
So that means how you're doing is, even if you have any change in S3 project, you are actually deploying the same version for
It needs to be
all
the same
other
version,
assets.
at least in the same project.
Domain.
So if you had a different project, then it could be a different version. But if you're going to update versions, you got to update them across the board, like all the way.
Okay, cool. And is it available for all asset types, like Lambda? I can create Lambda, SNS, SQS, anything I can think of?
Yeah, all of those constructs are, the ones that you just named at least, are in the open source repo. You can go and check and see if it's missing a construct. Again, like we haven't created every single service for every single, like we haven't created a construct for every single service, especially because AWS launches a service a minute at this point. So no, it's not, there's not every single service available, but most of the ones that you commonly know and have come to love and use are going to be available, and that's why we went GA in July.
Cool.
Yeah,
Thanks.
if you go to NuGet and you search the previous amazon.cdk, you'll see page after page of NuGet packages.
That's right.
Cool, thanks.
I can do that actually.
Well, your Docker
Okay,
build
so
run.
my Docker build. So I know that this is actually a bug with the CDK. So this is I thought I installed the latest version this morning, but maybe it didn't override the other version or something. Anyways, this code does work today. If you built it on your laptop, it would be fine. It's my laptop that's the issue.
Yeah, it is in the repo, which we'll bring up on the slide at the end. So, oh, there you go.
Well, don't get excited yet.
Okay.
This is where it fails.
Oh, yeah, okay.
Yeah, this was a bug that was fixed last month, so apologies.
Got it yet. Okay.
I must have the old version still on here somehow.
All right. Well, let's move on to the next one then.
Yeah,
I think.
let's do it.
All right. So we put together a sample. This is the next one is a serverless example of I was doing some talks recently about PowerShell Lambda, and I came up with a scenario. I'm a big fan of misheard lyrics. And there's nothing I like better on a rainy Saturday morning in Seattle than to play around with misheard lyrics. So I wrote myself a little app that uses Amazon Transcribe. And what I do is I take one of my music collection files and I listen to an old English band called Marillion had a Scottish lead singer. And I pass that to Amazon Transcribe, and I cheat a little bit because I tell it's an English US accent. So that's not going to work, but it generates some interesting stuff. So I put that into an S3 bucket, which triggers Amazon Transcribe to transcribe that, and then gives me the text output. And then I can have a good giggle and go back to whatever I was supposed to be doing that day. So I put together this sample. I'm not going to use a music audio today. We do have a simple audio clip of me speaking. But the way it works is we have 2 Lambda functions and 2 buckets. When you use transcribe, it takes an input bucket where the input audio or video is coming in. And there is a real-world scenario for this, right? Adding closed captioning on videos, okay? So there is a real-world scenario. This is not just playing around. takes an input bucket where you put the input video or audio, and an output bucket where it's going to write a JSON file, which is the actual transcribed text from that transcription job. Now, this is an asynchronous piece of work, right? So we start the transcription job, and then we just exit that Lambda function. And then at some point later on, the transcribe service will write the output JSON to the output bucket, which will trigger another Lambda to run, which is going to send me an email notification to say, hey, your transcription's done. Here's a link. Go click it. You can go and view it. So I translated the CloudFormation template that I had for that to CDK. And I can't remember what the exact size of the original template was, but it was fairly involved. So here's the actual transcription stack. So you see we have an input bucket, an output bucket, a language code, which I'll come to in a second, how we're passing this in, and then a Lambda function, start job function, that takes .NET Core Runtime 2.1 environment. You see I'm passing in some environment variables, okay, describing what's the output bucket, because I need to give this to transcribe, and the language code. The code that I want to actually upload to my Lambda function. In this case, I'm going to take that from an assets folder. So we have a build script that uses our .NET Lambda tools to do a build, effectively, of what we're going to deploy to Lambda and puts a zip file into the assets folder. They'll be picked up by the CDK, uploaded to S3 for us, and then registered with the Lambda function.
Another example of from asset.
Another example,
so cool.
Yeah. And then an event source. So my event source is going to be an object created in my input bucket is going to trigger this Lambda to run. Now, that start job function needs some permissions on it. It needs to be able to call transcribe. So here we've added a policy there that allows transcribe to run. And then also put bucket, because that's going to be passed to transcribe to allow it to write to my output bucket. And I'm giving grant read to the Lambda function so it can actually read from my input bucket. Otherwise, none of this is going to work. Then I'm going to create an SNS topic. And if I give this code a subscriber email, it's going to automatically add that email as a subscription on the topic. And I should get an email to say, hey, go and confirm the subscription, all good to go. Then we have a second Lambda function, the notify completion. Again, very similar to the first one. It just needs to know what's the topic it should publish a message to tell us that the transcription's done. The code for the Lambda function, and again, an S3 event source saying when an object is created in the bucket, go and run this function. We had some additional permissions to it. It's going to it needs to be able to call SNS publish. It also needs to be able to call getObject, because inside that Lambda function, I'm going to use our AWS SDK for .NET to get a pre-signed URL to the output file. And unless you give it the getObject permission, that URL will not work. Okay? We give grant write permissions to the Lambda function, and then the output of what's the input bucket name, so we know where to go and actually upload some content. Now, inside that code, I passed in two parameters, right? The subscriber email and the language code. Now, if you've looked at a CloudFormation template, we have that parameters section where we can put those in, okay? The way the CDK works is, and the way CloudFormation works is, those parameters are not resolved until deployment time, okay? So when the CDK starts to generate that template, it doesn't know what those values are. And in our code, in our C# code, we want to do branching logic based on those parameter values, and they're not bound at that point. So the way the CDK does it, and this is the preferred way of doing it, is you add a context. And you can pass these at the command line to override. So you can set some defaults and override them. So if you take a look at the folder hierarchy for this particular project, you'll see there's a cdk.json file. And in there, you can see I've set up empty string defaults for my subscriber email and my language code. Okay? When we deploy this, we're going to pass these on the command line.
Yep.
So I guess if we've done our .NET restore, we can try and get it running. This is one of those excellent examples of, I know it works on my machine. This is the first time we've run it on your machine.
I did click restore, but, okay. Oh, I did. It worked. Okay.
So the way we pass in those context variables is a -C switch to CDK CLI, right? So subscriber email equals your email. You can ignore language code. It'll default to English US anyway. Okay?
Go.
Let's go. Which folder are you in?
Not the right one.
Oh, did you build the Lambda functions?
No.
Cancel that then, for the moment.
All right.
Go back up. I gave you a PowerShell script. I forgot to tell you. My bad. I'm sorry. No, go back up to the root of the whole project. You see that build and deploy PS1 file? Actually, click on the build and deploy PS1 file that's in the project
here.
root. Yeah. So this is a PowerShell script that I wrote that takes the subscriber email as a parameter, and then if you take a look down the bottom, you see it's doing .NET Lambda package. It's calling our Amazon Lambda tools for the .NET CLI to actually do the build packaging of the zip file that we want to upload as our Lambda functions, and then invokes CDK deploy.
Oh no, I need to start a.
You need to be in a PowerShell script.
Hold on, TBD.
Well, you could do this from by hand if you want.
Yeah, it's not starting up PowerShell though.
No, okay.
Because it's in.
You're in Bash.
Yeah,
or
that's the problem.
Z shell or whatever that thing
Well,
is.
the new default is.
Okay.
Oh, it started up. Okay. I need to change the default to be Bash. 1 second. I think I can just go open the terminal and actually do that there.
Can you not just run Bash from inside your Z shell?
Can I just do that? Yes. Thank you. Dang it. Why? I might need to install PowerShell. I'd have my machine reimaged.
Nothing like that right before a demo.
Yeah, well, you didn't tell me I was going to be running a PowerShell script.
Well, you don't need to. Go back to the terminal. We'll do it by hand.
Oh, that was Windows. Okay.
We can fix this.
Okay, go.
So first thing, CD into the first Lambda function.
Which one?
Into start transcription
Start.
job, okay? And type .NET Lambda package. And then you need dash dash space dash dash. Can you just scroll up in the code and we'll just take you from there?
Yeah, we just copy it, right?
There you go. That's what we want, is that line there, yeah. In fact, you can CD up to the functions folder from there. CD backup 1. Backup 2, actually, I think. Functions, yeah, backup 2. Go to the root, yeah.
This is the root of the functions
Go
folder.
backup 1.
Okay.
There we go. No, paste it. Okay. Do you not have the .NET Lambda tools installed? Right.
No, that machine was reimaged.
.NET install tool, I believe, -G, no, space -G, space amazon.lambda.tools. I think that's the right command.
I actually think you're right.
You're going to tell me you don't have .NET installed as well, aren't you?
No, I do have .NET installed. That's a lie. That can't be.
Did I get the wrong way around?
Right. Yeah, I'll get out of Bash.
Okay, now try that again then.
Now it's no longer in the history. Cool. It's not my day. What was it?
.NET install, I think it's tool -G amazon.lambda.tools. Or was it .NET tool install? Type .NET. It might be .NET tool. I always get this the wrong way around. .NET install.
Tools,
Tools?
plural. Oh, at the end,
Oh,
it's
it's just-
tool here?
Yeah, no, tools there, yeah.
Okay.
Type .NET.
I'm not like joking. I really do have .NET
Okay.
installed.
So try .NET tool to flip it around. I sometimes get this the wrong way around. So .NET tool install -G amazon.lambda.tools. That
Like
looks
that
better.
one's gonna go?
That's quieter.
That one's going to go.
I like your confidence.
Yeah, I had to have my machine reimaged like a couple weeks ago.
Okay, we're done.
Back.
All right, so now we can paste that .NET command, those two, yeah, first one and second one. Let's get those zip files built. Or maybe not in your case. Could not start path users Nikki project reinvent demo functions. Oh, see, which folder are you in right now?
You told me to go to the root.
You're in serverless, right?
You want,
Yeah.
I'm in
LS?
serverless. Do you want me to go to functions?
No, type ls. CDK.
Dot assets. Slash
So it needs to be the functions
Oh,
folder.
it's
Oh,
just this.
there you go. Get rid of that. Yeah, get rid of that from your command then. This is why I put it in a script, so we could just run the script. But never
Well,
mind. There we go.
Should have given me a heads up.
I gave you the code this morning. What do you want?
I was in a breakout.
Hey, I did a breakout this morning on serverless development on .NET with my ex-colleague Norm.
I got your code when I was in a breakout.
Where he actually converted the project that we were using for the entire hour-long demo to .NET Core 3.1 last night.
What?
Right? Because it seemed like a good idea at the time. Now, it all worked fine.
What?
But, so this is easy by comparison.
At least I had .NET installed. Do I get props for that? No. I'm almost positive I did install PowerShell again, but apparently not.
I hope this works after this.
Yeah, me too. Guys, if you have questions, now's a great time.
Is it .NET 3.0 only, or
.NET Core.
Core 3.
Yeah.
Not 2.0?
Lambda functions for .NET Core need to be the .NET Core 2.1 runtime.
Are you talking
'Cause
about for
that's-
the CDK?
Yeah.
For the CDK, it doesn't matter. This is just because we're deploying .NET Lambda functions. It's .NET Core 2.1. You can use .NET Core 3.0 and 3.1 if you're curious, if you're in the room. You just need to use our custom runtime support. So .NET Core 3.0 is not a long-term support release, an LTS release. Lambda prefers to take LTS releases. 3.1 is. So now that it's released in GA, now the work will start on a new runtime.
Okay, they both built.
Okay, so now go to the CDK folder. Are we in the right one? CDK. Okay, and now execute your command with the subscriber email. And I will keep my hands tightly crossed behind my back. There we go. Got 3 minutes. It's a race against time.
Yes. Didn't work.
Oh, what did you do? No such file directory, snap projects, reinvent, demo services, assets. Where are the assets folder? Because you changed the folder hierarchy, right, when we built those functions.
The assets folder's right here.
Okay, which is above the CDK. So if you move that down to the CDK folder, then we should be able to correct the path. Okay, now try that again. Yep. That looks promising.
I mean, don't get excited.
All right, so there's the 2 zip files that have just been sent to S3, right? That's our Lambda code going out. All right, creating the change set.
Are you just like crossing your fingers?
I am. I've got these clenched so tightly, I can hear them cracking over the mic.
Cool. Guys, questions. Now's a great time. Help him
Yeah.
relax.
What? Yes, I believe. Well,
It's a
I
prop.
don't know if there's anything to help. It's just a prop on the
It's just
resource.
a prop on like every resource. So like, you know how I instantiated a lot of props when I created a bucket, when I did whatever? I think it's just a key in the prop. Yeah, well, you might be able to you could use a loop.
Yeah.
Kind of. You could loop through the existing things and then add it to the object.
Yeah.
I mean, you can use programming, right?
Yeah.
To like
It's full programming. right?
smartify
But
like, you can literally just like take all the objects that you created and loop through them and then basically add it to the prop object.
I mean, if the CDK did everything, we'd have nothing to do. Right? So we have to leave something. Okay, so it's creating
There are
some
ways
policies.
around that. I feel like there's got to be a way. Like we're smarter than that.
50
Just
seconds.
use your programming brain to write infrastructure, and then you're fine.
So you might want to go into the console right now
Okay.
and go to S3 with this account. I love a good race against time.
Okay.
So you should have a transcription input bucket somewhere.
This?
If that says input, that's the one. Okay, don't do anything just yet. How's the stack doing?
The stack is done.
Okay, so in your email, you should have a confirmation saying, hey, we have a topic for you. And we're at time. There it is. Cool. So that was a subscription that we added inside that CDK code to say, hey, add this user. Because I passed in a context value of subscriber email, if it wasn't set, I didn't add that in. Okay, so now just upload the audio file I gave you to that bucket.
You got it, dude.
And this is not a music file. I'm not breaking any copyright. This is an audio file of me correcting a webinar, which I don't think we'll listen to.
I really want to hear it now.
Well, you can play it once you've uploaded it. Okay, that should trigger our Lambda functions to start running. And this will take a minute or two to come through. So what I suggest we do is head back to the slides for a recap, and then we can come back to the demo.
I would get a notification in my email when it completes.
You'll get a notification in your email when it's done, yeah.
Cool.
Yeah, so if we can just switch back to the slides for a second, and we'll just go through our recap pieces. Okay, so recap then. So infrastructure as code with declarative templates. We kind of discussed what works, but what does not. You know, iteration, conditional logic is a little bit tricky. It's great. It's also not something I work in every day. I don't work in JSON every day. I don't work in YAML every day. I work in C# or other programming languages. So we talked about CDK concepts and tools, the idea of an app, which has composed of multiple stacks, each stack composed of multiple constructs, which can be chained together, the base level constructs that map to the AWS resources, and then the higher level constructs where we can compose logical constructs based on whatever rules and needs that we have. CDK bindings for .NET are just a collection of NuGet packages that you add just like when you're using the AWS SDK for .NET, and various bits of demos that we went through.
I got a notification.
Awesome. Awesome. Okay.
Okay, so
I'll bring the
all
slide
of
up at
these
the end.
demos that we built for you, even the ones we built for you
Yep.
live, are in this repo right here. I highly suggest you take a look at it also because .NET is so new, there's not many samples out there for the CDK. So we built a lot of I feel like the first samples essentially. So definitely check out our repo, steal from it, it's all yours.
Okay, so with that, thank you. We're going to head straight back to the demo right now if we can, very briefly, because she got her email. Feel free to reach out on Twitter, by the way, if you have any questions. But there is transcription complete. And when we log that, there's the pre-signed URL. Click that. We should get a JSON document, which is the transcription of me speaking, saying, hi, everyone, Steve here. In the Talgo ingestion demo in the live webinar, there was a problem. Oh, what a surprise. And me talking about the correction for the webinar, okay? Complete with time code, so if I wanted to actually add closed captioning, etc., I could. So
Cool.
that brings us to the end. Thank you very much.
Thank you guys.